Unit 5, Day 5, Proportions in Triangles. The side-splitter theorem states that a line divides two sides of a triangle proportionally if and only if it is parallel to the third side. So this theorem is given as a biconditional, which means that the conditional statement and the converse are both true. When we look at the conditional, this one tells us that if TU is parallel to QS, so we have TU and QS are parallel because of the arrows, then we can say that the side length RT over TQ is going to be proportional to RU over US. In the converse, this tells us that if you're given the measurements RT over TQ is proportional to RU over US, then you can conclude that the lines are parallel. So the difference between these two is going to be important based on the type of question you're asked and what your answer needs to be. This first type of example asks us to determine whether the statement is true or false and explain your reasoning. So we need to see whether this proportion is true based on the diagram given. When we look at segment DB, that's this one right here, then over BA, that's this segment. And we need to compare that with EC over CA. Now this is actually exactly what the side splitter theorem states, is that when you have this segment over this one, that's going to be proportional to this one over this one. Now you need to make sure that DB and BA are both segments on the left side. EC and CA are both segments on the right side. Also, DB and EC, the two numbers on the top, are measurements for this extended part of the second triangle. Then when you look at BA and CA, the two numbers on the bottom, those are the original side lengths of the smaller triangle. Therefore, we can say that the statement is true. When we look at the second one, we're going to compare it in the same way. AC is this segment here, and CE is going to be this segment here. BC is this segment, and DE is going to be this segment. Now when we compare these, AC and CE are both on the right side, BC and DE are both this long side or the parallel sides of the two triangles. However, when you compare them, AC and BC, AC is the whole side of the small triangle and BC is the whole side of the small triangle. But CE and DE, CE is just the extension on the bigger triangle and DE is the whole side of the bigger triangle. Because those two are not corresponding, this proportion is false. We need to find the value of each variable, so we're going to use the side splitter theorem and what we know about similar triangles to be able to set up a proportion. In this one, since the sides are parallel, we can say that 10 over 5 is going to be equal to 7 over x. Then once we set up this proportion, we can cross multiply. 10 times x is equal to 5 times 7, which is 35. Then we can divide by 10. Then we have x is equal to 3.5. Now let's take a look at the second example. We're still going to set up a proportion, but we need to be careful about the measurements we're given. X is the whole side of the small triangle. That corresponds with 20, the whole side of the small triangle on the other side. Then when you compare that with 50, 50 is actually the entire length of the big triangle. And that corresponds to the entire length on the other side of the big triangle. And the way we find that measurement is we need to take 20 plus 25 to give us 45. So this is the proportion that we need to set up. Then when we cross multiply, you get 45 times x is equal to 50 times 20, which is 1,000. Then we can divide by 45. And then we have x is equal to 22.5. In this set of examples, we need to determine whether the given information implies that BC is parallel to DE. So if we're trying to decide if DE is parallel to BC, we need to see if the converse of the side splitter theorem is true. So if 7 over 2 is proportional to 8 over 3, then those two lines will be parallel. So we can cross multiply. 7 times 3 is 21. 8 times 2 is 16. Because these two numbers are not equal, we can say that BC is not parallel to DE. When we look at the second example, we're going to do the same. We'll set up the proportion 6 over 9 equal to 4 over 6. We can cross multiply. 6 times 6 is 36. 9 times 4 is 36. And because these are equal, then we can conclude that BC is parallel to DE. The corollary to the side splitter theorem states that if three parallel lines intersect two transversals, then they divide the transversals proportionally. So if we have R is parallel to S and S is parallel to T, and then we have this line L and M that intersect all three of those lines, we actually end up with two different proportions. UW over WY is proportional to Vx over Xz, or you can say that UW over Vx is proportional to WY over Xz. In these set of problems, we're going to use the figure to complete the proportions. Now, in this figure, I need you to first see this small triangle ABC, the medium triangle ADE, and then the big triangle AFG. That's going to be really important as we compare each of the proportions. AB is the whole top side of the small triangle. AF is the whole top side of the big triangle. And we want to compare that to BC, the whole right side of the small triangle. So the whole top side and the whole right side needs to correspond with the whole top side and the whole right side of the big triangle. So FG will complete that proportion. In number 2, AB is the whole top side of the small triangle, and then DF is the extension from the middle to the third triangle. We have the top one blank. EG is the extension from the middle to the third triangle on the bottom. So the one that we needed on the top to complete that is this part, AC. When you look at this third one, we have AD, which is the top side of the middle triangle, compared to BD, which is just the extension from the smaller to the middle triangle. Then we want to compare that to AE, the whole bottom side of the middle triangle. So the part of the proportion that we need to match that, the corresponding side is CE. Find the value of the variable. So in this, we're given the fact that these three lines are parallel. We have this transversal and that transversal. So we can set up a proportion x over 10 equals 6 over 8. Then we can cross multiply. 8x is equal to 10 times 6. Then when we divide by 8, we get x is equal to 7.5. In this problem, we're not told directly that the three lines are parallel. However, when you look at these corresponding angles, the converse of the corresponding angles postulate tells us that we can say that these three lines are parallel. Since they're parallel, we can use a proportion to solve for x, and this one I want to set up differently than our first one. We can set up x over the corresponding side 3 is equal to 9 over the corresponding side 3.5. Then we can cross multiply and we get 3.5x is equal to 9 times 3, which is 27. Then when we divide by 3.5 on both sides, we get x is equal to 7.7. Now the last theorem we want to talk about is the triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So you need to be careful here because we have this triangle and ray CD is bisecting angle C. It also happens to cut this segment AB into two segments. However, AD and DB are not equal to each other. CD only cuts angle C in half, but what ends up happening is that this side gets cut so that you have proportional side lengths. AD over DB is equal to CA over CB, or the other proportion is AD over CA, the two sides on one half of the triangle, is equal to DB over CB. So whenever you have this type of problem, first thing I want you to do is identify the bisector. That kind of cuts our triangle into two halves. So when we set up our proportion, we're going to take these two sides of the triangle, the far side, or the side opposite from the angle, over this side, and we're going to set that equal to, again, the other side of the triangle, the side opposite from the angle on top, and then the corresponding side, 6 on the bottom. Now we can cross multiply. A times 4 is 4a, equal to 3 times 6, which is 18. Then we can divide by 4, and then we have a is equal to 4.5. When we take a look at this problem, you identify the bisector, and when we set up our proportion, we can put x over 5. Now the side that corresponds with 5 on the bottom of the proportion is the side 8. The only thing we're missing is this side length right here. We don't know the measurement of that side, but we do know that the whole side BD is 7. Whatever this part is, BC, that plus CD is going to give us 7. So if x plus the length of CD equals 7, we can represent CD by subtracting x from both sides, and we get CD is equal to 7 minus x. So we're going to represent this blue segment with the expression 7 minus x. When we put that in here, before we cross multiply, we need to put that into parentheses, so that when we cross multiply, we get 8x is equal to 5 times 7 minus x. So then we get 8x equals, don't forget to distribute. Then we're going to add 5x to both sides. And then we have 13x is equal to 35. Once we divide by 13 on both sides, we end up with x is equal to 2.7. And that's it.